So, this video we can give some basic then operation of how to make a helical gear. So this is a horizontal milling machine. The horizontal milling machine mainly used for making flat surfaces and make grooves and using different types of tools here. Now we are fitting one tool here. This is a gear cutter. This is a 14 dp gear cutter. So now we can try to give some demo about how to make a helical gear. So for helical gear we need some adjustment for this is the dividing head. Dividing head is mainly used for can rotate the workpiece in equal angles. So you can fit the workpiece here in between center. We have two centers here. We can fit the workpiece there, and we can rotate this from the dividing head. That means the 1:40 is the gear ratio inside the dividing head. You can rotate this to 40 revolution. It will rotate only one revolution. And in this machine, it has a 3-axis machine, and this one for the Y direction, this lever for the Y direction, and this lever for the X direction, and this one for the up and down movement Z direction. So it's a 3-axis machine. Gear cutting. The exercise is into this is a 50 mm diameter is about 50 mm and thickness is about 15 mm. And then you need to make a maximum number of teeth in your given blank. That is exercise. So for that, this is very difficult to fit it on the machine. The thickness is very small. So for fitting this workpiece on the machine, we are using this mantle. This is called a mantle. So with the help of this mantle, we can fit the workpiece on the machine. So that is how to. This is the method. We can lose this and we can fit the workpiece here and we can tighten it. So after tightening, we can fit the mantle on between center here. So before that, you need to reduce the diameter. So we need to do some calculation. Mainly the dimensions given is lead of the helical gear is 24 inches and DP, the cutter DP we are using is 14 inch. Okay, actually the main formula, one formula is OD is equal to D plus 2A and D is equal to N by dP cos theta, and some formula is for calculation. So according to we can find the angle, the theta we can find that the theta is we'll get 13.44 degree and the number of teeth we will get 24 numbers, and the outside diameter we got 48.4 mm. So almost this is 50 mm that you need to reduce to 48.4 before cutting the gear. So according to 24 number of teeth from the equation we will get 48.4 mm diameter. So now we are going to use lathe for reducing this diameter before cutting the helical gear. So with the mantle, the workpiece we can fit on the chuck. Actually this is a three-jaw chuck. This will has self-centered chuck. So no need for centering. So we can fit the tool here. So first you need to reduce the diameter to 48.4. So this is 50 mm. So according to our calculation, we will get 48.4 for 24 number of teeth. So we can switch on the machine. Tool edge, you need to do some chamfering. this is the model for, this is our workpiece for helical gear. So the helical gear we already reduced diameter to 48.4 and fitted on the mandrel, and on side of the mandrel we need to fit this part. This is called a lathe dog. So lathe dog is used to transfer power from chuck to the mandrel. So we are fitting here in between centers. That's it. So we can fit here. So we can fit the mandrel in between centers. Here we can tight it well. Center will tight it well. This also will tight. Okay, fit the tool here. Already the 14 dp gear cutter we already fitted on the machine there. The work is also fitted, and you need to, in this portion we can cut the, after giving depth you can cut the first teeth by using this lever. So you can cut the first teeth. After cutting the first teeth you will rotate your workpiece in a steady position. So every time you need to rotate. So actually our so for example, we have a number of teeth with 40 number of teeth, gear blank with 40 number of teeth. The angle between two adjacent teeth is 9 degrees. That means 360 by 40 you will get 9 degrees. So every time you need to rotate the workpiece in 9 degrees. Actually, the dividing head also, one revolution of this one, the 40 revolution of this one, it will rotate one revolution. So one revolution of this crank, the chuck will rotate only one revolution. That means it will rotate 9 degrees. Same 1:40 is the gear ratio. The same angle you will get 9 degrees. So it is very simple to make a 40 number of gear blank. So every time you need to rotate this to one full revolution, you will get 9 degrees there. So now we have only 24 number of teeth. So we need to find the angle. That is more than 9 degree. We need to rotate. So for that, you need to calculate this. You can use this plate. In this plate we have some equally spaced drill holes are there. And each row, the number of holes also mentioned there. The topmost row have 29 holes and the second one is 27. So which row you need to select, that you need to calculate. So for that, you need to using formula 40 by n. So 40 by number of teeth. So 40 by 24, you will get 192 by 3. So 192 by 3 means you need to rotate one full revolution plus 2 by 3 of one revolution you need to rotate in every time. That means 9 plus 1 by 2 of 9 makes 6 degrees. So total 15 degree, I think 15 degrees the angle. So for getting that angle, so you need to rotate this to one full revolution plus 2 by 3 of one revolution you need to rotate. That is formula. You can use the formula by 40 by n, 40 by number of teeth. That means 40 by 24. 40 by 24 means you will get 192 by 3. So 192 by 3 means you can select that is second row. Second row is total number of holes is 27. So for 27 you can divide into 3. So 9, 18 and 27. So we can start from here. So after that, after cutting the first teeth, you need to rotate this to one full revolution plus 2 by 3 here in this portion. After that, from here you will rotate this one revolution plus 2 by 3 here. So that's why you need to, every time you need to rotate in 1 and 2 by 3, 1 and 2 by 3 like that. So you will get the exact angle on your gear blank. So for helical gear, some angle is there. Actually, the table already tilted for some angle. So already that is the angle is a theta. Theta is 13.44. Already we set this angle here. So we can lose this nut. One nut is here, lock nut is here. We can just lose it, and we can easily tilt to the angle. With any angle you can select. So according to our calculation, 13.44 is the angle of this helical gear. So already we set to 13.4. So after that we can give the depth by using this wheel. So first you need to switch on the machine and touch the cutter on the workpiece. That is set to the dial to 0. This is a dial. You can set this to in some initial position you can set. So from there we can give the depth. So that you need to find the depth also. So for that finding depth you will get you can use the formula 2.157 divided by dp. 2.157 divided by dp. That is a formula for finding the depth. 2.157 divided by 14. The dp is 14. Already the cutter of dp of this cutter is 14 inch. So you will get 0.154 inches. So 0.154 inches, you know, convert into millimeter, you will get 3.9 millimeter. So 3.9 means the maximum depth of this thread gear is 3.9 mm. So we can't give directly 3.9 mm, you know, to divide into two steps. So actually this dial, one small division of this dial is 0.05 mm. 0.05 mm. So 3.9 divided by 0.05, you will get 78 divisions. So total number of total depth of the helical gear is now we will get at 78 division. So that we can divide into 2 means you can first 40 division. After that you will get 38 division. In 2 steps you can do. So you can start the machine here. Start the machine here. And after that you can use this wheel to touch the workpiece to the cutter. This wheel for the up and down movement just up the workpiece. So now it is touching. Now it touched. So now it is touched. This dial you can set to your initial position. So you can set this to 0.5. 0.5. And you can lock it. So now it is the initial position 0.5. So from 0.5 we can give the depth. So from this initial position we can give the depth. Okay. So first we can give 40 divisions. Total depth is 78 divisions. So first we can give 40. So from 0.5 to 1 is 10 division, 20, 30, and one full revolution, one complete revolution is 40 divisions. 40 divisions. After that, after completing the whole number of teeth, after completing the whole number, you need to rotate this to same direction, this direction to 38 division here, only up to here. This total is 40. So after giving depth, we can switch on the machine. Now it's in initial position. Dividing head also in initial position. You can switch on the machine. You can start now. So after completing, you need to return to the initial position. You need to return to the initial position. Then you need to rotate this dividing head. So the dividing head, actually it's I told you earlier that 1:40 is the gear ratio. And you will rotate this to one full revolution. This will rotate only 9 degrees. So now you need it to 15 degrees. So 1 and 2 base is our calculation. So from here, you need to rotate this to one full revolution plus 1/3, and this is 2/3. It will be marked. 9 holes, 18 holes and 27 holes. So already we rotated, and again same process we can repeat. Now after completing, You need to turn back. Again, this one you can rotate to one full revolution plus 2 by 3 here. Start. So like that you need to complete all number of teeth in all 24 number of teeth. After completing the 24 number of teeth, this lever you need to rotate. For that you can give 38 division again, and same process you need to repeat 24 number of teeth. Again same process you will repeat for the all 24 number of teeth. You need to give more depth 40 plus 38, 2 steps you need to do. So one more thing. In helical gear, here we have a lead. So actually, in our calculation, we gave a 24 inches lead for the helical gear. So for getting 24 lead, you need to adjust this some gears here. So actually, this is the driver here and this is the driven here. This is the driven here. This is some intermediate gear, any gear you can use. And this one is a driver and this is the driven here. That will rotate to the, you give the lead for the workpiece. So the formula is driver gear by driven gear is equal to lead of the machine divided by lead of the helix. So the lead of the machine is 8 and the lead of our workpiece is 24. So 8 by 24 you will get 1 by 3. So 1:3 is the gear ratio. So for 1:3 you know set this is the driver gear is 10, number of teeth is 10 and the driven gear is 30. So 1:3 is the gear ratio here. So you will get a 24 lead for the workpiece. The lead of the machine is 8 inches, 8, and our workpiece lead is 24. So this is a helical gear we are doing. This one is the completed helical gear. We already finished this one. All 24 teeth we need to give, and the maximum 3.9 mm depth also we need to give in 2 steps. So this is very important. The indexing is very important, and you need to do it perfectly. Any row you can select according to your calculation. Now we are selecting 27, total number of 27 holes. So to 1 and 2 by 3 you need to rotate it perfectly. Otherwise you will not get the same correct angle there. So every teeth, after cutting the teeth, you need to every time you need to rotate 1 and 2 by 3, 1 and 2 by 3 like that. So this is the basic operation for how to make a helical gear. Thank you.